Now, I don't know about you, but it feels to me like we've been waiting for propagation cycle 25 for quite some time. But at last, it seems like it's just about to start. But what can we expect from it across the bands? And will it be all good news? Well, we've just the person to tell us, because it's a very warm convention welcome to the chair of the RSGB Propagation Studies Committee, Steve Nichols, G0KYA. Hello, Steve.
Yes, good afternoon. How are you?
I'm good, thank you. It's been a busy day, some great talks so far and more to come. How about
Excellent.
you?
Excellent. Not too bad. Thank you.
Good. Well, we're
So
really
we,
looking forward to you inspiring us now and telling us this really is just round the corner now.
well, yeah, okay. I mean, I title this presentation Solar Cycle 25, the good, the bad, and the downright ugly, because everyone raves about solar maximum and what we'll be able to work. But there is more to it than that. The good side is that we have a higher solar flux index. Therefore, we have more ionization. We have bands opening up all over the place. The bad is that we get increasing number of solar flares, which could knock out the HF bands for maybe an hour, maybe 2 hours. And then the downright ugly, which is associated with solar flares, are things called coronal mass ejections, which are ejections of large amounts of solar matter, plasma, if you like, that come away from the sun at maybe 500 kilometers a second. And these CMEs can be as big as the Earth or bigger even. And when they hit the ionosphere, it really does knock it for six. So we could find that we have days when the bands are not very good at all. So you have to take the rough with the smooth, I'm afraid. But anyway, let's have a look at Solar Cycle 25, where we are and what the predictions are. So this is where we are in the cycle. I downloaded this yesterday, so it's as up to date as I can get it. And you can see there that we're now coming into the late 2021, obviously, and that the solar flux or sunspot number there was shown as being 50. And in fact, the prediction is at the moment we are actually ahead of the game. We're actually ahead of the prediction, which initially was that we would have the solar maximum in June 2025 with a predicted value smooth sunspot number of 115. And we're actually ahead of the game, if you like. Now, I wouldn't read too much into this because it can zigzag up and below the band as we go along. As you can see from Solar Cycle 24, there were certainly times when we were above a prediction, and there were certainly times when we were below the prediction. So I don't think it's a done or a sealed deal that we're going to be ahead of Solar Cycle 24 anyway. But that's a prediction anyway. And Lisa Upton, co-chair of the NOAA NASA Solar Cycle 25 prediction panel, said in 2019 the prediction was that Solar Cycle 25 would peak in July 2025, plus or minus 8 months, with a maximum sunspot count of 115, plus or minus 10. And what we have to bear in mind here, this is a prediction panel. So this isn't one person's idea. This is a panel, and they have to agree on where they think things are going. And if current trends hold, Solar Cycle 25 could peak as early as 2024 and be similar in strength to the relatively weak Solar Cycle 24 that preceded it. Now, Solar Cycle 24 wasn't a ground breaking solar cycle by any means. In fact, it was very, very weak. And no sooner it started, it seemed to be ended. So it's if we have a Solar Cycle 25 as similar, all I'm really saying is if there's DX to be worked, work it now and work it when you hear it. Don't hold on for better conditions because they may never arrive. So sorry to be so doom and gloom about it, but that's the way it goes. Now, the predicted maximum was, as I said, originally June 2025, but they've now kind of brought it forward a little bit, maybe to June or later in 2024. And this is based on the fact that things have ramped up a little bit earlier in 2021. So the new best fit curve, if you like, and how you can work out a best fit curve just from that little bit of data, I'm not too sure. But they're now looking at maybe 2024, mid 2024. So this is good news in that it now means you've got 3 years left until the maximum. So you've got 3 years to sort your stations out, 3 years to get your antennas sorted out, 3 years to learn Morse code if that's what it takes. And 3 years to basically prepare for the maximum of Solar Cycle 25. But even now, we are seeing the early signs of activity. I mean, for example, over the last 2 weeks, 10 meters has been opening up. And what we will see is 10 meters opening up to FT8, probably initially. Then it will open up to CW and then open up to SSB. We're not seeing the fantastic conditions on 10 meters SSB that we might see as we get further into the cycle, but things are ramping up. I mean, yesterday, for example, I worked VP8 on FT8, that's the Falkland Islands, and there were a lot more stations as well. And I was starting to see North American stations coming in, which is always good. And we'll see that improving over the next few weeks as we head into late autumn. But this prediction or this presentation is really aimed at the amateur who's never seen the peak of a solar cycle. Some of us with grayer hair than others will remember solar cycle 24 and 23 and maybe even 22. So this is really a kind of a look at what you can expect to work in solar cycle 25 and what we can expect to see in terms of the downside of solar cycle 25 as well. But there is always a but, isn't there? There's one prediction that says we will have a massive solar cycle 25. And this was from Scott McIntosh, and this was produced in Solar Physics publication. And his best estimate for the amplitude of solar cycle 25 is, now this is interesting because I can't, oh, there, 233. I have a little pop-up that was covering the figure, I couldn't see it. So he thinks that we have an amplitude of 233, which is phenomenal, really, with a 68% confidence that the amplitude will fall, but somewhere between 204 and 254. And also with a 95% confidence, it would be somewhere between 153 and 305, which isn't saying a lot, to be honest. I would have thought that we will definitely get something between 153 and 305, but whether we'll get this massive peak, I don't know. Scott McIntosh is definitely putting his reputation on the line on this one, I think. But it just shows you that there are no finites in ionospheric physics. There's no finites in solar physics. We have to best guess it based on what we know. So what I've done is all the predictions in this presentation are based on a smooth sunspot number of 115. So I've gone with the solar cycle prediction panel, and we'll see where that takes us anyway. Right. So anyway, just to go for the good and the not so good then. So the good is that we'll have increased maximum usable frequencies. Yep. The upper HF bands will be open to DX. So we'll see 15 meters, 12 meters, and 10 meters opening up to DX, where largely they've been pretty dead over the last few years. The bands will remain open later. In fact, you'll get to the stage where 20 meters may be open through the night, which is good. There will be fewer coronal hole issues. Now, coronal holes are something we've been suffering from on the downward part of the last cycle, but they are areas on the sun with open magnetic field lines, and they're a little bit cooler. So if you photograph them in extreme X-ray, you see them as black patches. But coronal holes have open magnetic field lines, which means that they, rather like a CME in effect, they contribute to the fast solar wind coming off the sun, and that can drive down the MUFs. So we should have fewer of those going into the cycle anyway. They generally happen on the downward part of the cycle. So for now, and we are starting to see them disappear. They're not as prevalent as they were maybe even 6 months ago. We'll have more long path openings. By long path, this means that you may find that you can work, say, Australia in the morning and in the evening, depending on which path it's the signals take. And 6 meters might even open up as well. If the flux is high enough, 6 meters suddenly opens up to F layer DX. So it's quite an exciting time. Now, that's the good. And you'll notice that the not so good is actually a bigger list. Wouldn't worry about that too much. But the not so good is that we get increased solar flares. These are massive explosions on the sun, and we'll look at those in a minute. Increased number of coronal mass ejections, as I said earlier. Absorption on the lower HF bands. So you may find that 80, 40, maybe even 30 meters suffers from higher absorption when the sun is out, when it's daylight. So you have to go up in frequency to get the DX that you want. Coronal holes, as I said, can be a problem, but should be worse after the maximum. So once we get past maximum, coronal holes may increase. 40 and 80, not so good due to D and F layer absorption, and top band, not so good due to D and F layer absorption. So in other words, for the lower bands, we've probably had the best conditions that we will have maybe for this cycle. So I think the focus is, as we head towards solar cycle 25 maximum, is focus on the higher bands, 20, 15, 12, 10, that kind of area. But the lower bands, I'm not saying that you'll never work any DX on 40 and 80, but it may be easier to work DX on the higher bands anyway. Now, just to remind us, this is what the sun looks like at solar minimum on the right. This was March 2009. And solar maximum, July 19th, 2000. As you can see, absolutely peppered with sunspots there. That's pretty typical, and I would hope that we'll see the sun like that on solar cycle 25. You'll notice that there are sunspots in the northern hemisphere and the southern hemisphere of the sun. And this is not unusual at all. In fact, what you find is that one hemisphere usually peaks before the other one. So you get a double peak in terms of the sunspot maximum as one peak takes over from the other one. And that we've seen that on a number of cycles now. They're out of sync slightly. So we don't get the same number of spots in the northern hemisphere as we do in the southern hemisphere. So we'll probably see a double peak to solar cycle 25, but we'll have to see. So solar flares, mentioned them earlier. What are they? Well, they're massive explosions of energy on the sun. And that electromagnetic energy arrives in about 8.3 minutes or thereabouts. And that can cause a sudden ionospheric disturbance on the daylight side of the Earth. So the way of thinking of it is, if you could be working somebody on maybe 20 meters, and it's like somebody flicking a switch. It is that bad that the signals will just disappear. And they could disappear maybe for 30 minutes, 20 minutes, 30 minutes, maybe up to an hour. The absorption in the D region, this is the region that gets ionized by this radiation, affects the lower HF bands more. And we find that the ionosphere can recover quite quickly, with the higher bands recovering first. So if we do get a sudden ionospheric disturbance, you'll find that 10 meters will recover first, then 15, then maybe down to 20. But you'll get very little warning of these. And as I said, it'll just be like somebody switched the band off. But the good news is that they are relatively short-lived, never really longer than about an hour, unless they're absolutely massive solar flares. But they are something to consider. But as I said, if you're working on HF and everything just disappears, and you check your antenna and everything seems fine, it's probably a solar flare that will be reported on solarcycle25.com in due course. And as we get towards solar maximum, the sun produces about 3 solar flares or CMEs every day. So this is where at the moment it's maybe something that happens maybe once a week, maybe twice a week. We could end up with 3 solar flares every single day. So the chances are you are going to hear the effects of a solar flare. Now, this gives an indication of what a flare does to the ionosphere. This was when the sun was overhead, roughly in Mauritius, that kind of neck of the woods. And you can see that the big red blob shows you we've got absorption there up to 35 megahertz. And as we peel away from that, you'll see the absorption goes down until we get to the UK. And there is an effect there, but it's nowhere near as bad. So you can see that the attenuation there is much, much less at 28 megs at 10 meters. But as you come down to 14 megs and 7 megs, the attenuation goes up dramatically. So again, this is just to re-emphasize that the lower bands are going to be hit hardest and recover latest, or the latest recovery when we get a solar flare. But they are something we're going to be seeing quite a bit of in solar cycle 25. Now, associated with solar flares is something called coronal mass ejections. This is basically just like the sun burping and throwing out solar matter. And there is literally tons of the stuff when this happens, moving at up to maybe 500 or more, 550 kilometers per second, not per hour, per second, which is very, very fast indeed. Now, not every solar flare results in a coronal mass ejection, but if we do have a solar flare that occurs somewhere on mid-latitude on the sun, maybe towards the center of the sun, then we can probably expect to see that impact the Earth maybe 48 hours after we've seen this CME. So if you see a solar flare or you hear a solar flare, chances are there's a CME associated with it. And it may be that in 2 days' time, we're going to get a solar CME effect. And the way we will recognize these is we'll look for the KP index increasing. So the KP index could go from 2 to maybe 5 or even 6, or massively even to 7. And the KP index gives a measure of how the Earth's magnetic field is being distorted by this material coming in. Now, it could be that the CME misses the Earth completely. If the CME occurs on the edge of the sun, it doesn't necessarily have to hit the Earth. It can fly by, misses completely. But if it does hit the Earth hard on, then the KP index is going to go up. The usual effect is for reduced MUFs. The maximum usable frequency will be crushed, if you like. It'll be reduced. And it can take a few days to recover. It may take 2 or 3 days to totally recover and get back to where we were. And in that time, you could get another CME hit. So this is why everyone raves about solar cycles. This is what we're going to get. But you get the CMEs as well. So it's not always good news. Other good news about CMEs, they affect the poles more than the sort of mid areas or mid latitude areas. So signals that go over the poles are going to be affected more. So if you want to work maybe Western Canada, you may find it harder to work it. What you may find is there's either no signals at all as a result of the CME, or the signals that go over the pole are very, very fluttery. That's usual as well. But it does mean as well that we're more likely to get aurora. So you might want to go up to 2 meters and try auroral propagation as well. But we're going to concentrate on HF today. But so that's the coronal mass ejection. I said millions of tons of solar matter being ejected at a massive speed, and usually about 48 hours to hit the Earth. But watch out for the KP index rising. And if the KP index rises to 5 or 6 or thereabouts, expect MUFs to decrease and expect that for it to take maybe a couple of days to recover. Don't worry, this is not all going to be doom and gloom, this talk. So here we go again. So severe geomagnetic storms are most likely during the equinox seasons, or most frequent when the equinox seasons. And this is due to the layout of the sun and Earth. And so when the equinox, what you find is that you're more likely to get a magnetic storm impact the Earth. The other thing is that the polarity of this plasma, the magnetic polarity of this plasma, is important. As this plasma is ejected from the sun, it has a frozen-in magnetic polarity. And we talk about the BZ, the interplanetary magnetic field's magnetic polarity. And if this BZ is pointing south, that means it will couple more easily with the Earth's magnetic field, and you're more likely to get an effect. If the BZ of the plasma coming in is pointing north, it's not going to couple with the Earth's magnetic field, and we may not see the effects at all. So the BZ is very important in terms of knowing whether the CME is going to have a massive effect or not. And the further south it's pointing, the more likely it is to recover, to couple with the Earth's magnetic field. But as I said, just to confirm it, most likely effects are noted with signals that pass through the auroral oval. And that's usually far western Canada and northern states, and across the other way to Japan as well. So there we go. Now, just to show you the effect of a coronal mass ejection, this was 27th of August 2001. The KP index reached 5, and you can see that as the CME hit here, this is a a plot of maximum usable frequency, and you can see that as it hit the Earth, the maximum usable frequency started to die out and go down. And there's sunset there. So the MUF had gone from about 17 megahertz down to, what's that, about 12 megahertz before the sun had even set. So this is pretty typical of what happens with a CME, that you get this depression of maximum usable frequency. And this can, as I said, last a couple of days before we start to get recovery again. But there is a small uplift just before the magnetic storm hits. You sometimes get a little bit of an initial phase or pre-auroral enhancement when signals seem to go up before we get the main phase when signals die down completely, and then we get the recovery. I tried to do some work on this last solar cycle, didn't get very far, but I'm going to certainly have a go at this solar cycle to try and predict how soon we get the initial upward phase of a CME effect, and try to work out just how strong that initial effect is. But it's very tricky because you don't quite know when the CME is going to hit the Earth. So it's going to involve a lot of time and a lot of work. But it's best to start doing this work when there's lots of CMEs about. That's just why I've left it for this solar cycle. But then again, so here we go. So the initial phase of a CME hitting the Earth is a positive phase. So you might get an enhancement on signals. Things go up. You think, well, this is okay. Don't know what the trouble is. Then you'll find that the KP index really does go up, ramp up completely, and signals die out. And then we get the recovery phase during the geomagnetic storm. And coronal hole effects, I just mentioned them again, not a problem as we head up towards maximum, but they will tend to occur once we start going down the other side again. We've just gone through a whole period of CME effects, sorry, coronal hole effects, and we're now in a situation where they're less and less. But there are areas of the sun with lower energy and open magnetic field lines, but they add to the high-speed solar wind and can cause geomagnetic disturbances with increased KP index. So not a problem on the way up, but certainly once we get past maybe 2024, 2025, we'll have more coronal hole effects. Again, we may find MUFs being depressed by these coronal holes as we head towards minimum again. So we said there that the prediction is for a solar smooth sunspot number of 115. So what does that mean in terms of solar flux index? Well, this is a graph of solar flux index on the left against sunspot number along the bottom. And you'll see it's not a straight line. There isn't a hard and fast tally between the two. But on average, there is an equation at the bottom there. 0.6 of the sunspot number plus 67.02 gives you a rough solar flux index. So 115 is roughly equivalent to an SFI of about 136. So that's what we're supposed to be getting as a maximum on this solar cycle 25, an SFI of about 136. Most propagation prediction programs generally use smooth sunspot numbers. Excuse me. So I'd stick with using SSNs, I think. But if you want to look at what that means in terms of an SFI, solar flux index, about 136. And just to recap, the solar flux index is a measure of the sun's strength measured on the Earth, at the Earth, at, I think, 2800 megahertz, 10.7 centimeters anyway. And they call it the 10.7 solar flux. So this is a measure of how much ultraviolet activity is coming off the sun, but measured at a much, much lower frequency. And there's some correlation there between how many sunspots there are and the solar flux strength. But it's just generally easier to work with sunspot numbers or smooth sunspot numbers with the programs. So as I said, an SFI 136 will be roughly equivalent to 115 solar sunspot number, but we'll have to see as we get onto the cycle. Okay, now this is a graph of a path between the UK and New York in October. And what I've done is I've plotted there, this was done in W6EL prop, but this is a path that was measured and predicted for solar flux levels of 66 and 275. Now, 275 is an awful lot bigger than 136, which is our prediction, but it does show you that at levels of 66, you can see on this path, it peaks around about 4 o'clock in the afternoon. And previously, you may have got 17 meters open at that point. But at solar maximum, you'll see that it's open on 28 megs from around about maybe 1 p.m. to around about 8 p.m. And that's the difference. What we'll find is that 10 meters opens up an awful lot earlier and closes a lot later on paths like this, when in fact at solar minimum a couple of years ago, you'd never heard America at all on 10 meters. But this is what we're going to get. We're going to find the band opening up, and you'll be able to work the world on 10 meters over a larger period of time. And we'll look at that in more detail right now. So this is, again, using VOACAP, and this is a prediction program. So this is the maximum usable frequency between the UK and New York in October for smooth sunspot numbers of 10, which is what we had maybe 6-7 months ago, and a smooth sunspot number of 115. So this, if we look on the left here, we see that the maximum usable frequency on that path from the UK to New York in October was probably about 18, 19 megahertz. But now look, sunspot maximum, it's off the scale. It is way up over 28 megs, 30 megs or more than 30 megs actually. And so again, from roughly 12 o'clock in the afternoon or midday, right the way through till nearly 6, you're going to have 10 meter openings. And it's up there at maybe 100%. In other words, 10 meters is going to be open to the States nearly every day, and it will be like clockwork. In fact, I remember the last solar cycle, I got fed up with working the States on 10 meters. It was open every day. And you get some fantastic DX as well. We're just talking about New York on this case, but when the bands are open, they're open everywhere, as we'll see in a second. And I chose 2000 earlier, and the reason is 2000, 2001 was a massive solar peak. It was also when 9/11 happened, and I heard the tragedy of 9/11 on 10 meters on one of the repeaters on 28 megs, the K2QH repeater, I think it was actually on the World Trade Center and was broadcasting what was going on in America, and I heard it on the radio that afternoon. So that shows you what you can actually hear. It was not a good thing to listen to, I can tell you, but that's the sort of DX you'll be getting. You'll be getting 10 meter repeaters open into the States and into the Caribbean on 10 meters, and again all afternoon, maybe every afternoon in the right months. October is probably the best month for DX. Right, so let's have a quick look at the charts then. I've used VOAPROP here just to show you very graphically what you can expect to work. So this is VOAPROP, 3 o'clock in the afternoon in October, with a smooth sunspot number of 10 on 10 meters. In other words, look at that. There's hardly anything to be worked at all. There is a slim chance of working, Western Africa, but hardly anything. So let's crank it up then. What do we get with 115? This is the same chart, same time of year, same time of the day. And as you can see, on 10 meters, you'll be able to work an awful lot of the world. So there we've got South America opening up. We've got the Caribbean. We've got East Coast of the US opening up. And we've got most of Africa and also Middle East as well, which is pretty typical of what you might expect to hear on 10 meters. So the moral of this story is, as I said earlier, get your antenna sorted out, get your station sorted out. Definitely get an antenna going for 10 meters. It's probably the easiest band to put an antenna up for, the smallest antenna of all the bands we've got, or HF bands that is. But do get something going for 10 meters, because it's a band that you really don't want to miss as we approach maximum. This is this is VOAPROP again, 4 o'clock on 15 meters this time. We'll go with 15 meters and a smooth sunspot number of 10. So this is solar minimum. And you can see there that actually it's not too bad. You've got some openings maybe to South Africa, and maybe some little few openings there to the northern part of South America, but not phenomenal. But now let's crank the smooth sunspot number up. So there we go. That's putting it up to 115. Now you see that you've got the whole of the states opening up. You've got the whole of Africa opening up. You've got propagation maybe to the Indian Ocean, to the west coast of Australia. If that doesn't float your boat, I don't know what will really. So again, 50 meters is another great band, and that will be opening up more and more as we head towards solar maximum. So again, if you want to look at your antennas, certainly focus on 15, 12, and 10 meters. These are the bands that are going to make such a difference to us. And again, this is 20 meters, but I want to show you something about 20. This is 20 with a smooth sunspot number of 10. And you can see there we've got Africa opened up in October and the east coast of the US. But if we crank it up to 115, you'll see that we get openings there to the Middle East, and we get openings up to Asia as well. But it's not, if I flick from one to the other, you'll notice it's not that phenomenally different. In other words, what we're going to see is, yes, we'll definitely get more signals on 20 meters and more DX on 20, but you won't see the same effects that we're seeing on 10 meters. And I think that's quite telling, actually, that the bands that we will see the biggest effects on are the higher bands, such as 15, 12, and 10 meters. Yes, 20 meters will come into its own and will work very, very well, but you will see the greatest effects on the higher bands. Okay. Now, I said earlier that the HF bands will stay open a lot longer at solar maximum as well. This is Veropop's prediction of 2300 UTC in October. On the left, we've got smooth sunspot number of 10. And on the right, we've got our smooth sunspot number of 115 again. And you'll see that at 11 o'clock at night, at sunspot maximum, an awful lot of the world, the band will still be open. So the bands will be staying open a lot longer on HF, which is good news. I mean, what we normally find on 10 meters is it starts to close down as the sun sets, and then closes quite rapidly close after sunset. The 20 should be open almost 24 hours, which will be good fun as well. So don't just think, oh, well, the sun's gone down now and 10 meters is dead. That's it. I'll switch off. Just come down in frequency. Come down to 15, come down to 17, come down to 20 meters, and see if that actually works a lot better for you, because there will be DX to be worked around the world, probably all night long, especially in the summer. The band 20 meters stays open a lot later in the summer, through the night, even at sunspot minimum almost. So again, 20 meters will become a nighttime band rather than a daytime band maybe. Because the absorption will be higher on 20 meters during daytime. So you may find that 20 meters is a band to move to at night. And good luck for your DXing there. Now, what else can we look at then? Well, something I've said is that 28 megs beacons will come into their own. I've shown the chart there that shows you the NCDXF International Beacon Project beacons, and you can listen to these now if you want. They're a chain of beacons around the world that operate on 14 megs, 17, 21, 24, and 28 megs. I won't tell you the exact frequencies, but you can actually look at the ncdxf.org URL there and go and have a look. And all you have to do is tune on to the frequency you want, say 28.2 megahertz, and listen to what comes in. And if you listen in a 3-minute period, you will hear, they're in Morse code, but it doesn't matter. Even if you can't read Morse code, you can work out which beacon it is, because there's an indicator on the website that will show you which beacon is actually transmitting. And over a period of time, you get used to hearing that RR90 is exactly sort of didard it, etc. So you'll, even if you don't understand all the Morse code, you recognize a beacon quite quickly just by the first two characters. But these, you will find that as we head towards maximum, more and more of these beacons, the International Beacon Project, are going to be audible. And at the moment, I think you might hear OH2B in Finland, RR90 in Russia, maybe Madeira CS3B. But as we head towards maximum, you'll suddenly find a lot more of these becoming audible as we go out through the day. So that's the 28 megs beacons. Well, actually, that's not it's all the beacons from 20 to 10. But what I wanted to mention was that there are hundreds of beacons operating on 28 megahertz. And many of these operate at power levels below 10 watts. Now, we keep a list of them. There is no official list because they come and go, daily virtually. And there is a list on the RSGB website there, and it was compiled by Martin G3USF and the Propagation Studies Committee. Try and maintain that list now. We've made probably about 200 changes to it, I think, in the last year. But it will just show you. And the great thing is that if you go down the bottom end of 28 megs, when we're at sunspot maximum, you'll hear all sorts of things. You'll hear 3-watt beacons coming out of the States nearly every day. And the great thing is to just drop the beacon owner an email with your signal report, because they like to hear where their beacon's being picked up. But the list grows and decreases because these things come and go. People in America, they can put beacon up and take it down again. So it's very, very hard to keep the list up to date, short of emailing everyone saying, hey, is your beacon still up? But it's not unusual to hear beacons from all over the world and operating at much, much less than 10 watts. Some of them 10 watts beacons, some of them are 5, some are 3 or even 1 watt. And even in Europe, we've got some 1 watt beacons that you can hear every day when conditions are good. So that's another thing you can do on 28 megs. 28 megs is the lowest band where beacons are actually allowed to operate. So unless you've made a special case for operating a beacon on maybe 20 meters, you can't really operate a beacon there. The International Beacon Project has got dispensation, if you like, to operate on 20 meters, but there really shouldn't be any other licensed beacons on say 20 meters. And so we generally look at 28 megs as the lowest band that you can actually have beacons on, and you can apply and get a license to operate a beacon on this band, and away you go. But it's a good way of checking for propagation. Obviously, it's not the only way of checking for propagation now, because we've got FT8, we've got WSPR, we've got the reverse beacon network. So there's lots of tools now to hear where signals are coming from. But if you use all these tools together, you'll get a feeling for how propagation is improving and where you can actually get to. But anyway, have fun with the 28 megs beacons, and do send an email to the beacon keeper if you do hear one, maybe in the States. They really do appreciate it. Okay, now I did mention earlier working or listening to the events of 9/11 on KQ2H. Now, KQ2H was a 10-meter repeater that was based on the World Trade Center in the New York State, and was obviously destroyed in 9/11. But it was rebuilt, and it's now in the Catskill Mountains of New York State, and it operates on 29.620. Now, there are dozens of FM repeaters on 10 meters worldwide, and they are generally from 29.6 to 29.7 megahertz. And in fact, the repeater channels are even. So if you start at 29.6, which is generally thought of as the calling frequency for 10 FM, then you find that you'll find repeaters on 29.620, 640, 660, and 680. Now, how do you work these repeaters? Well, they use 100 kilohertz shift. So you have to have a repeater shift of minus 100 kilohertz. In other words, if you're transmitting or you're listening, say, on 29.620, you have to transmit on 29.520 to get into the repeater. And some of them have a CT-CSS tone. For example, the KQ2H that I mentioned in New York State has a tone or needs a tone of 146.2, just like 2 meters. You know, if your local repeater has a CTCSS tone, it's the same with 10-meter repeaters as well. But the thing about these repeaters is, or especially KQ2H, is the power. It runs 1.3 kilowatts. So I found this report online that said the signal for hours on end swings to full scale diffraction. That's 5.9 plus 60 dB. That's how strong it is. So when the skip is really, really running, when conditions are really going well, you can hear the KQ2H repeater on 29620 every single day, and it's loud. Very loud. You can hardly mistake it. But there are others. It's not just that beacon. Repeater. There are other repeaters in New York, and there are repeaters around the world. I remember there was one in Puerto Rico last solar cycle you could hear every day. But the reason I just picked KQ2H is it's, of course, with 1.3 kilowatts, it's probably one of the loudest repeaters you can hear. We've got them in Europe as well. We've got the repeaters in, for example, Switzerland. There's a repeater in Switzerland on 10FM that has its ID, which is a musical box. It plays a musical box tune. I can't remember what it is, HB9HD, I think it is. So there are something worth playing with. There's something worth listening to. You have got a lot of fun listening to 28 megs repeaters. And obviously, they work very well when you're mobile. So if you operate mobile, then you can probably get into one of these repeaters quite easily with a rig putting out just maybe 10 or 20 watts. There's a number of monoband 10-meter rigs around, and they're ideal for listening to repeaters. But they're good fun anyway. I think 28 megs repeaters are often forgotten about. We forget that they're even there. But listen to 29620, and sooner or later, I think over the next few months, or maybe next year, we'll start hearing KQ2H coming in again. And you'll know that it's the Catskill Mountains of New York State. And that will be the repeater that I would listen for first of all. And there's also simplex operation as well on 10 meters. So there's FM simplex on the odd channels in between the repeaters, so such as 29, 610, 630, 650, 670, etc. With the calling frequency 29.6. So if you call CQ on 29.6 and you make a contact, move on to one of these other odd channels, keep away from the repeaters, and you should be okay. But definitely do try 10FM. It's a great band, great mode, and excuse me. You should be able to work the world. There have been contacts with Australia on 10FM. Absolutely. I've heard Australia on 10FM, and it's so much easier to work when you're using a repeater as well. So that's really it for what we can expect in Solar Cycle 25. I hope I've given you some ideas for operating on the bands in that time. As I said, you expect the higher frequencies to come alive, expect the higher frequencies to come alive earlier and go to sleep later, as it were. The lower bands, such as 20 meters, expected to stay open a lot later as well. And I've just given you some more information, URLs here. Solarham.com is a great site for keeping up with what is the current sunspot number, what is the current SFI, what are we doing, what's happening in terms of CMEs, has the K index gone up? So it's a good overall starting point for what's going on with the ionosphere. Services.swpc.noaa.gov, again, got more information on the smooths, or the sunspot cycle anyway, and that's where I got the chart from where we are in Solar Cycle 25. In terms of prediction software, the ones I've used to produce this were vocap.com, which is an online version of vocap, so you don't need to install it on your own PC. I used voaprop to come up with the graphs here that show you the world and the places you can work on the world, and that was produced by G4ILO, Julian Moss, who's now sadly Silent Keys, no longer with us. But it is a very, very simple little piece of software that runs on PCs that can easily show you what's workable and what isn't. Then we've got predtest.uk, which is the RSGB sponsored software that uses the ITUR HF prop software. So again, you don't have to install anything on your PC, or I say PC, you can use any device to connect to predtest.uk, and it can do area predictions, and it can do point-to-point predictions. So if you want to work out the best time to work, say the Falkland Islands, predtest will do a great job for that. And Proppy is an allied piece of software that also uses ITUR HFprop, and that can be found at soundbytes.asia. And then finally, there, I just mentioned propquest.co.uk, which is our own Jim Bacon G3YLA site, which takes the information from Digisons and then plots them on a real-time basis, so you can see what's happening in terms of to the ionosphere on a minute-by-minute basis, basically. And it will also then predict the maximum usable frequency over different path lengths as well. So it's a great utility, it's a great tool, and in the summer it also has predictions for sporadic E with a dialogue on there that Jim does a kind of a blog every day saying where you should be able to work with sporadic E over the summer. So it's a great one to bookmark and use. So that's it, David. That's the information. I suppose we better get round to questions now, if that's okay with you.
Wonderful, Steve. Thank you very much. Well, there is something to look forward to, although it's still 2 or 3 years in the building, I guess. And I think what I've taken from that really is 10 metres or 28 megs is the one to start with, at least. That's probably
Absolutely.
our best hope, isn't it?
Absolutely.
Okay, well, thanks very much for those. Yeah, we have got a couple of questions for you, Steve. Firstly, from Paul G0VKT, what's the difference between A and K index?
Okay, right. That's a good one. You would think, why would they bother having 2 separate indices? That's a good question. The A index is a linear measure that goes from about 0 to hundreds, really. So, and it's updated on a 24-hour basis. So I generally use the K index, which is updated every 3 hours, which gives you a more up-to-date measure of geomagnetic disturbance. They both measure geomagnetic disturbance, but the K index is updated every 3 hours. The A index generally updated every day. The K index is a logarithmic measure, so it goes from 1 to, I think it goes to about 9, but you generally don't see K indices of 9. So if it goes from 1 to 4, that is quite a massive change. And you can equate K index to A index. So going from K index of 1 to 4 is probably going from about 10 to about 50 on the A index. But as I say, I generally don't use the A index now because it's not updated regularly enough. And the K index will tell you what happens in the last 3 hours. And what you generally find is that most prediction programs use the K index, and there's an awful lot more talk about the K index now rather than the A index, because it tells you, the A index will tell you really what happened yesterday, but it doesn't really tell you what's happening. In fact, it's possible to have a high K index but a low A index because everything's happened today. But yeah, so the K index is updated every 3 hours and is logarithmic. And the A index is updated every day and is a linear method. That's the easiest way of putting it. So I generally would look at the K index because that will tell you what's happened in the past 3 hours.
Thank you. Ronnie Buckland's just made a comment that it's great to see VKO land being available. A Tim G5TM says, does higher sunspots mean 40 improved at all for Inter-G?
Yes, it does. Didn't really mention that. That's a good point. What we've had is lower MUFs over the sunspot minimum, and basically the highest band that you could work around G was probably maybe 80 meters or maybe 60 meters, 5 megahertz. But he's absolutely right. As we get more ionization, 40 meters becomes an inter-G band. which is quite important actually. So you will find that you can work around the UK on 40 meters because the higher ionization is just making it make it work for you. What's happening is that at the moment, on signals that go upwards, which is what you need around the UK, you need near vertical incidence sky waves, so near vertical incidence signals going up. And at the moment, they're going straight up, and on 40 meters, they're going straight out into space. And as we get more ionization, we'll find the MUF, or the critical frequency, actually is going up, and it'll go above 40 meters, and you'll suddenly find that you can start working UK on 40 meters. So that's a really good point, and one I didn't make, which is thanks for pointing it out. But yes, so just to recap, 40 meters will become an inter-G band as ionization goes up. Absolutely.
Thank you. Yeah, and in fact, Per Einar Darlin, I hope I pronounced your name right, Per, 40 metres becomes as good as 80 metres during sunspot maximum, and better signals on longer domestic QSOs too.
Yeah,
so,
absolutely.
Lots of people saying thank you very much. We're really out of time now, Steve, but thank you very much for that. We've got a lot to look forward to, and I shall remember your talk because you described the coronal ejection, I think it was, like the sun burping, which I thought was a wonderful way to sum up. Thank you very much indeed to Steve G0KYA. Thank you.
Okay, thank you very much.